Hi, in this section we're going to be expanding what we know about sets and set operations from 2 sets up to 3 or even more than that possibly. So we already talked about the commutative law for union and intersection, basically that A union B is the same thing as B union A and A intersect B is the same thing as B intersect A. Now we can also add to what we know the associative law for unions and intersections. So if you have 3 sets and they're all unioned, basically it doesn't matter which one of those you do first. So it says like I could take B or C and then whatever I get from that, combine that with or A. I could do it in that order, or I could switch the order and do A or B first and then add in the or C afterwards. And it doesn't matter what order I did that in. Same thing with ands. As long as they're all ands or intersections, you can do them in any order you want. But notice those are the same symbols. And then there's also a distributive law for unions and intersections. So you can kind of see how that works. If I have A or the quantity, the set B intersects C, I could actually do 2 different unions and intersect those in the end. So it's just different ways to look at the same things. And that those are just laws that end up being that you can go through and you can prove those if you wish to. We're not going to take the time to do that here. I just want to show them to you. And then as a reminder, we do have our De Morgan's laws. Those are really helpful, important laws where if you take the union of 2 sets and you complement that, that's the same thing as taking each complement separately and doing the intersection. Same thing works for the other way around. Okay, so let's go ahead and practice with some 3 sets, and let's start with some Venn diagrams and some shading. So in part A, it wants us to do A intersect B intersect C complement. Okay, so if I kind of want to write that in words, we want to shade everything that's in A and in B and not in C. That's how I can kind of write it in words. So I can do this, again, that associative law basically says I can start wherever I want on here. So perhaps I would like to just start at the beginning and say, well, where is A intersect B? A intersect B would be this center slice where A overlaps B. So that's A. Everything in there would be both in the A circle and at the same time in the B circle. And then what's not in C? What if I add this third part to it? So I'm going to go through and shade with a different color everything that is not in C. So I'm just making some lines outside of the C circle. So I have that first intersection in blue, and then I have this second part in red, and I need to do the intersection one more time of where I have both blue and red now. And so what you can see is it's kind of just the upper part of that original slice. This is the area that is in A and B and also not in C. So color coding can help on these just like it can with when you're graphing inequalities. Okay, let's look at the next one. This one says A union, and then it has in parentheses B intersect C, close the parentheses, complement. Now, I like to do this one probably maybe working kind of from the back up, because first we maybe need to figure out, well, what would be in B intersect C? And we want to be outside of that, right? We want to be outside of this. So the intersection of B and C would be this yellow part. So we want to keep everything outside of that. So I'm going to do that in blue. Everything outside of just that little area. And then I'm going to actually go through and I'm going to erase that so that I don't keep it and think that that's a shaded part. And now I want to do or, because this one's a union, or in A. So I need to shade everything in A for this one. And then what I keep is because this one, the main symbol was an or, I want to keep anything that's shaded anywhere right now. So what I end up keeping is everything except this one tiny little slice that's inside of both B and C, but outside of A. If you can kind of see that. I keep everything, even this part, everything at all, except for one tiny little piece. So maybe I'll say like that this part in a different, only this little part is unshaded. So the different colors can really help. Okay, and then let's see. The very last one we have inside a giant parenthesis set A union B union C, and then we want to take the complement of that entire thing. So we're looking for what's not in A union B union C. That's what the complement means, not in there. So first we might think, well, what is in A union B union C? Okay, that's anything in the A, B, C circles, overlapped, not overlapped, anything at all in there. So that would be, I'm going to maybe dash it in, put some little dots. That'd be anything inside any of the circles. But what we want to keep is everything not in there. So I'm going to just kind of zigzag shade everything that's not in those circles. So all my purples are my final answers on these. If you want to look back at that later. Okay, so I was practicing with some Venn diagrams and some shading. Now let's use our De Morgan's laws to rewrite some different set operations, because sometimes it's just easier to look at them in a different way. Okay, so we have A union, the B intersect C complement. So this one's coming from above. So this one comes from part B above. So how could we rewrite that with a De Morgan's law? Well, the De Morgan's law is going to apply to this back part that we're taking the complement of. So the A union is going to stay the same. And then by De Morgan's laws, we can rewrite this back part as B complement union C complement. And it's as simple as that. Just apply that rule to that back part. Now, how can we apply, or can we apply a De Morgan's law to more than two sets? The answer is yes, you can. So you can have as many unions as you want, and if you take the complement of all of that, that De Morgan's law applies to all of them. So it will turn this one into A complement intersect B complement intersect C complement. So you can apply it across the board like that. When you add the complements to each set, you just have to flip over the symbols.